Okay, we're looking at example 3, section 4.1. So this is the sum and difference rules for taking derivatives of functions using the power rule, basically combined with sum and difference rules. So we're given for part A, y is equal to 4x to the 5th minus 3x to the 6th. And so again, the idea here is that basically we just take the derivatives of these two functions totally separately and just subtract the derivatives. So it's pretty straightforward for the sum and difference rules. So the derivative here, dy dx, will be equal to, so basically what we did in the previous example, same thing, take the 5, multiply it by the 4, we get 20x to the 4th power. And then from here we multiply the 6 by the 3, get minus 18x to the 5th power. So that's A. For B, similar. Now we've got a root within that function as well. So f of t is equal to 3t to the 4th power minus 9 root t. And so again, the idea here is that before we actually use the power rule, we want to write any roots as exponents. So 3t to the 4th power. Square root is the same thing as a 1/2 power, so we get 9t to the 1/2. And then at that point we can go ahead and find the derivative, f prime of t, and then we'll just use that power rule combined with the constant root multiple, and then also combined with this idea of taking a derivative of a difference. So the 4 times the 3 is going to give us 12t to the 3rd power minus, multiply the 9 by the 1/2, I get 9 over 2. T, lower that power by 1, I'm going to get negative 1/2 for the exponent. And again, if I want to write this with positive exponents and roots and or roots, we can change that second part of the problem to be 9 over 2, and then the negative again moves it to the denominator. The 1/2 means it's a root. So if we want to, we can write the answer that way. Finally, for part C, this function maybe right away doesn't look like we can use the power rule on it because it doesn't look like it's a power function right away. So we'll have to rewrite the function a little bit before we can actually use that power rule. So this is the function. Again, it doesn't really look like a power function as it is, so we have to alter it a little bit. So I'll leave that alone. We'll write this as, let's go ahead and write this immediately as a 1/2 power. Remember, that's really the first thing you should do with any roots. Write them as powers. And then from here, what we can do is split this up as two fractions. So we can write this as 2x to the 4th power over x minus 5x to the 1/2 power over x. So that's the trick here. When you have just a monomial in the denominator, just a single quantity, single term, what you can do if there's 2 or more added or subtracted in the numerator, just split it up so that each term separately is over that denominator. And then we're going to use so we're still not taking a derivative at this point, we're still just rewriting the function. Then we're going to use our properties of exponents to rewrite this. So I've got x to the 4th power over x to the 1st power. 4 minus 1 is 3, so this is going to end up being 2x to the 3rd power. Remember what you do when you have powers, you have x to a power divided by x to another power, you subtract the exponents. So on this one, we've got a 1/2 power. That's a 1st power, so 1/2 minus 1 is negative 1/2. So I'm going to get 5x to the negative 1/2 power. And again, remember that this is g of x. We haven't taken the derivative yet, so now we'll take our derivative. We'll say g prime of x is, now we'll use the power rule on this. Put the 3 in front, multiply it by the 2. We get 6x squared. And then on the second part, move the negative 1/2 down, multiply it by the negative 5 that's there, so it becomes positive 5/2. So we get positive 5/2. Lower that power by 1. So this is negative 1/2. If we lower that by 1, we're going to get negative 3/2. So again, if you want to write this as positive exponent and or with roots and powers instead of, or with roots instead of fractional exponents, we can rewrite this as the negative will push it to the denominator, so we get 5 over 2, this is going to be x to the positive 3/2 power, which again, if we want to write that with roots, this is really just for practice, we can write it as 5 over 2. The 2 in the denominator there of the exponent means a square root. The 3 in the numerator means a third power, so we got a square root of x to the third power. And so that's the derivatives of these three functions, again, basically using variations of the power rule for taking derivatives.